Welcome to the project demonstration of battery management system by using INA219 along with Arduino Uno. So here mainly we are going to calculate the voltage and current from the INA219 which is a power monitoring sensor module which is communicated through the I2C module, so which will provide us the voltage and current continuously. And the next, temperature of the battery pack whenever the battery is charging or discharging, that is continuously measured with help of DS18B20. So in real time we need to place this near the battery pack. So whenever the load is connected, so parallelly we are going to measuring the temperature from this temperature sensor of the battery pack and the current and voltages when the load is connected from this INA219. Then the system will calculate the SOH. And also whenever the battery voltage is less than 8.5 volts, there is a dead voltage, then system will on the electromagnetic relay to charge this battery pack. And while charging the battery also, we are going to continuously measuring the temperature of this battery pack from this DS18B20. Then we are going to calculate the SOC values. SOC main input is voltage values as well as temperature of the battery pack. Coming to the SOH, current, voltage and temperature of the battery pack. So totally 5 parameters: voltage, current from this sensor, and temperature from this sensor. And the next SOC, SOH values will be calculated based on the voltages and these 3 parameters. So these parameters continuously displayed on the LCD screen, and which are interface that to the Uno board at pin number 227, A4, A5 for this INA219 module, and the buzzer connected the pin number 11th pin, 8 and 8th pin is connected to the relay board. These are the main interfacing connections between the input and output modules. And temperature sensor at the pin number 11th pin, that is the DS18B20. So here the main power is 230 volts AC input to this transformer. So the transformer will step down the 230 volts AC to 12 volts of AC, and that will be converted into the DC with help of this regulated power supply board, so which has the mainly 2 stages: rectification with help of this 4 diodes which will act as a bridge rectifier, and then output is pulsating DC of 12 volts, and the pulses will be removed with help of this capacitor which will act as a filter. There we'll get the constant of 12.5 to 16 volts, that is a VRMS voltage after pulses removed. That is the input to this battery pack through the relay, and that same voltage is input to this LM2596 voltage regulator. So the purpose of this voltage regulator is operating voltage of our Arduino board and some other modules is only 5 volt. So that 12 volts will be regulated to the 5 volts with help of this LM2596 voltage regulator. The output is given as input to this breadboard. From there we are going to distributing the 5 volts power supply throughout the input and output modules, and this is a main on-off switch to provide the power supply to this load directly. And coming to the main components: transformer, regulator power supply board, electromagnetic relay, battery pack 12 volt 1 amp, so which has a 3 4 volt 1 amp batteries are connected in series, so we'll get 12 volt 1 amp. LM2596 voltage regulator to step down the regulator 12 volts DC to 5 volts of DC, INA219 current and voltage measuring module, and this one is the breadboard to distribute the 5 volts power supply. Main processing unit is the Arduino Uno board, 16:2 LCD screen, and buzzer whenever the temperature is crossed the threshold value, then we'll get the audible alerts through the buzzer. So let us see the demonstration. This is the only power supply to charging the battery pack. So just on the power supply to this circuit. There we can see the SOC, SOH values continuously monitored and calculated displayed on the LCD screen. And the next, voltage and current. So V is a 12.7 volts and I is a 00 milliamps. Now when we on the load is connected, and there we can see the temperature as well as current is 21.3 milliamps of power consumed by this load directly here. So we can see that continuously. And coming to the temperature also, so whenever degree this increases, as you can see, slowly the temperature is getting increased. Again coming to the normal. Right. So here we are using Coulomb counting method to calculate the SOC values. SOH directly based on the voltage when it is charging the battery pack voltage. As of now, it is fully charged. That's why we are showing the and normal temperature. That's the SOH is going to be the 94.16. SOC, SOH both are in percentage. Voltage in V and I in milliamps. Temperature in degrees centigrade.